All right, welcome back. Welcome back. We are starting our discussion of the membrane transport, different types of membrane transport. First, a general concept that we need to agree on. So, if you work at a job that puts this amount of pressure on you, this is job A, and you've got another job offer that would pay you the same. So you're not getting extra money, but with less pressure on you, less tension. Which one would you choose to go to? Would you remain at high pressure, or would you like to go to the other jobs that will put less pressure on you? What do you think? Or the one with less pressure, definitely, right? They are the same in terms of money, so I will be moving from high pressure to low pressure. How about this is a job that you have right now. It puts set amount of pressure on you, and you've got a job offer from another company, but they will put this amount of pressure on you. This is company B. Would you go from A to B? What do you think? Is there any condition where you're gonna go from A to B? What do you think? You won't go, right? You will not be going from a job with low pressure to a job with high pressure. What if this job that you have right now pays you $1,000 a month, and the new job that would put a lot of pressure on you would pay you $5,000 a month? Would you go or not? What do you think? Yes, here we go. You need to pay me for me to go to the job with higher pressure, right? So this is the exact concept for anything and everything, including the molecules. But the molecules, what is the type of pressure is their concentration. So if we're looking here at sodium, let's say. So what makes the sodium at low pressure or high pressure? It's a matter of comparison. You're comparing two sides. So if I told you I have one sodium per each liter, so I have 1 liter of water and I have in this liter just one sodium, compared to 10 sodium per liter. Which one is gonna be at higher pressure? Which one gonna be at high pressure? If I'm telling you you are the sodium, you're gonna live by yourself in a house. And I told you now you've got family coming in and you are 10 people in the house. Would you feel high pressure if you are on your own, or high pressure if you are with other 9 people? Which one is higher pressure for you? Higher concentration of people in the house or less people in the house? More people in the house means high pressure. So high pressure for the molecules means what? Higher concentration. And what I mean by higher concentration, do I mean by higher concentration? Is it the number of sodium? No, it's not the number of sodium. It's not the amount, the number of people. So if I told you you are 10 people, but each one has his own house. So you have 10 houses, you are 10 people. So is there any difference between this one, let's say this is A and this is B? Is there any difference in terms of pressure or concentration? If you are 10 people in 10 houses, is there any difference compared to if you are on your own in a house? Is there any difference? Can you see my point on here? We have 10 people and each one has his own house. Is there any difference when you compare it to just one person living in his own house? One house. It's gonna be the same. So would there be any difference in pressure here between those two? There is no difference in pressure. So pressure is determined by what? Not the amount, not the number of people. The number of people in terms of number of houses. In our example on here, it's going to be the number of sodium moles per water. So the concentration and the pressure are going to be determined according not the amount, but what again? Concentration. And the concentration or osmolarity is going to be determined according to number of moles of the solute per number of liters of the solvent. So in our example, this is going to be the sodium and this is going to be water. Do you agree with me on those concepts? Do you agree with me on those concepts? So you're going to be moving from high concentration to low concentration, from high pressure to low pressure. I don't have to pay you extra money to move. You did it on your own. I didn't have to pay you anything. No extra money on here. But when would I need to pay you? I need to pay you if I'm telling you to move from a job with much less pressure to another job with much higher pressure. All right, if those concepts, those are very logical concepts, very logical concepts. If you understand those concepts, you will be able to understand all the membrane transports that we're going to discuss in a minute. So please make sure that everything that we've mentioned so far is clear. Do you have any questions? Any questions? All right. So those are the primary factors here that will determine whether you're going to be allowing the membrane transport or not. And the other factor is going to be the chemical structure of the molecules. So if I'm dealing with a molecule that is lipid soluble, What I mean by lipid soluble is soluble in fat, soluble in lipids. It doesn't love water. Like, for example, fats or pesticides or the ointments that you use on your skin. Those are lipid soluble structures. So if I have a lot of them on the outside of the cell, if I am exposed to insecticides, pesticides, and this is my cell, I don't have pesticides in my cell, what's going to happen? Those are lipid soluble. Would they be able to travel through the plasma membrane? Can I travel through the phospholipid bilayer if I am lipid soluble? What do you think? Would there be any limitation for this membrane transport to take place? No limitation. I can simply pass. I am lipid soluble and the structure of the membrane is lipid. So I can simply pass through the lipid membrane. I can simply pass from high concentration to low concentration. So those pesticides would pass freely to the inside of the cell until when? Until I have the same concentration on both sides of the membrane. Here, the membrane is not limiting the passage of the lipid soluble molecules or solids. So what do we call this type of transport in which I'm dealing with lipid soluble solute? This is a simple diffusion. And simple diffusion, did you pay anything? Did you need to consume energy? This is how you pay in order to allow this membrane transport to take place. What do you think? Do you need to pay in order to allow this lipid soluble substance to trouble down its concentration grade? Did I have to consume energy? This is how I pay in this sense. No energy consumption. So we call this as a passive transport. So what's passive transport? It takes place without you consuming energy. The substance is traveling from high concentration to low concentration, from high pressure to low pressure. It will be taking place on its own. I don't need to consume energy for it to be taken place. What if I'm dealing with something like the sodium, for example? Sodium is a positively charged ion. I have lots of sodium outside, lots of sodium outside, lots of sodium outside. Compared to the inside of the cell, I have much less sodium present. Would you be able to allow this sodium to travel to the inside of your cell, passing through the phospholipid bilayer? Can this sodium travel through the phospholipid bilayer? No. Why? Because remember, the phospholipid bilayer has a hydrophobic part. It doesn't allow water-soluble substance to travel. So what will I do with this sodium? You can't get it in. It can't move in on its own. In order to allow it in, you need to have sodium channels. I need to have sodium channels. If I do have sodium channels, would I need to pay for this sodium to travel into the cell? Would I need to consume energy? Would I need to convince this sodium to move into my cell? do you require energy for this to take place? What do you think? Do I need energy to allow the sodium in? Remember, when did I have to pay you? If you are moving from low to high, did I have to pay you if you're moving from high to low? No. Here, is this sodium passing from high to low or low to high? It's passing from high to low. So do I need to pay you to get in the cell? Yes or no? No. So you don't need to consume energy in order to allow the sodium in. Why? Because the sodium is passing from high concentration to low concentration. But it can't pass like the fat soluble, lipid soluble, through the plasma membrane. It requires you to have a channel, sodium channel. So this is a passive transport. It's a passive transport. It's a type of diffusion like the previous one, but not a simple diffusion. It's a channel mediated, facilitated diffusion. So here, in order for the diffusion, for this passive transport to take place, it required me to have a channel. Here I have sodium, it's water soluble, it cannot pass here, it cannot pass through the phospholipid bilayer. But if you do have a channel for this sodium to travel, what's going to happen? It will simply pass from high concentration gradient to low concentration gradient. It doesn't require me to consume energy. No need for energy to be paid in order for the transport to take place. So we call this as a passive transport. And what type of passive transport is it? It's a channel mediated facilitated diffusion. How about this here? Okay, I'm dealing with glucose. I have a lot of glucose outside of the cell. Compared to the inside of my cell, I have much less glucose. Can this glucose pass through the phospholipid bilayer? Remember, glucose is polar, so it's water soluble. Can it pass through the phospholipid bilayer? What do you think? Can I pass through the fatty acid tails of the phospholipid bilayer? I can't. So sodium cannot travel to the inside of the cell by simple diffusion. I cannot. It's polarized. It's charged. It cannot pass through the fat part. How about having a channel? If I do have channels, would I be able to allow this glucose to pass in? Still no. Why? Because the glucose is too large to fit in a channel. Glucose is too large to fit in a channel. So what will you need to have? You need to have a larger protein that will be carrying the glucose to the inside of the cell. So I need a carrier. So if you do have carriers for the glucose, would you need to pay for the glucose to travel in the cell? What do you think? Would I need to consume energy to allow this glucose in? No. What else? Anybody? If you do have carriers for the glucose to be transported, would you need to have energy consumed to get this glucose in? Would you need to pay for this glucose to move in or not? What do you think? Am I moving from high to low or low to high? I'm moving from high concentration gradient to low concentration gradient. So would you need to pay me to allow the transport? No. So what do we call this transport? If I don't consume energy, I'm transporting a solute. It's a diffusion. But what is this diffusion different from the previous one? It required not a channel, it required a carrier. So what do we call this diffusion? It's a carrier mediated, facilitated diffusion. So again, what did we mention so far? We mentioned that if I am transporting a solute from its high concentration gradient to its low concentration gradient, it doesn't require me to consume energy. It doesn't require me to consume energy for me to allow this transport to take place. It will take place on its own. This is a passive transport. What do we call this passive transport, in which the solute is the one that is traveling, either lipid soluble, water soluble, that has a small structure like the sodium, or water soluble that has a large structure like glucose. All those are solutes that you are transporting. The passive transport in which you are transporting a solute, it's called a diffusion. But are all of them going to be conducting the same diffusion? No. Lipid solubles, they can pass through the membrane. So this is a simple diffusion. It doesn't require anything to take place. How about the sodium? Can it pass through the phospholipid bilayer? It cannot pass through the phospholipid bilayer. It required me to have a channel. So we call this transport, it's a channel mediated, facilitated diffusion. How about the glucose? Something larger than the sodium. It's a more complex, it's C6H12O6. So 6 oxygen attached to 12 hydrogens attached to 6 carbons. So it's a large structure. It cannot travel through a channel. It requires me to have a carrier. So this is a carrier mediated, facilitated diffusion. Any questions? Any questions so far? Anything which is not clear? Questions? Questions? All right, so let's have a look on here. I have 10 moles of sodium per liter. And inside the cell, I have 4 sodium per liter. So which side has a higher concentration of sodium? What do you think? Outside or inside? Which side has a higher concentration of sodium? Outside, all right? Outside. So if I'm telling you that this cell doesn't have channels for sodium, I don't have channels for sodium, but I want to equalize the concentration of the sodium on both sides of the membrane, what would I need to do? Can I equalize the concentration of sodium on both sides? So let me do it in a different way. So this is you, and this is, for example, your friend. And you are doing the same job in 2 different companies. You have this amount of pressure on you, and your friend has this amount of pressure on him to do the work. You cannot go here to help your friend. So how can you reduce the pressure on your friend? If you cannot move, what you can do, you can get some of the work to travel here. So what's another option that you have? If the sodium cannot travel, what else can travel that we have in here? I'm telling you, we do not have a channel. We don't have a channel. Is there any way I can equalize the concentration on both sides without channels? All right, so just bear with me. I have high concentration of sodium, right? You have a problem with this? Outside of the cell. And you have lower concentration of sodium inside the cell. You cannot allow the sodium to move. How can I equalize the concentration on both sides? What do you think? Is there any way I can equalize the concentration of sodium? Yeah, here we go. You can move water from one side to the other. So let's do this. Can you tell me the concentration of water on the inside of the cell? What is the amount, what's the concentration of water in terms of sodium? So concentration of sodium is 4 sodium per 1 liter of water. So the concentration of water is 1 liter of water per 4 sodium. In other words, it's a quarter per liter per sodium. Do you agree on this? Do you agree on this? Caroline. All right, so what we're doing here, I'm telling you is that outside of the cell, you have 10 sodium per liter. And inside of the cell, you have 4 sodium per liter. You agree on this? So which side has higher sodium concentration? Outside. Great. So I cannot allow the sodium to move. Why you cannot allow the sodium? Because this cell doesn't have channels for the sodium. Remember, in order to allow the sodium cannot travel through the plasma membrane, so it required me to have channels. I'm telling you that this cell membrane that we're looking at doesn't have channels for sodium. Is there any way I can equalize the concentration of the sodium on both sides, knowing that the sodium can't move? This was my question. And some of you did answer that you can move water. So we're looking here at the concentration of water, not the sodium, the water, in terms of sodium. So here, having 4 sodium per liter inside means you have a quarter liter for each sodium. For each 1 sodium, you have a quarter liter of water. You have a problem with this so far? All right. So how about outside? What is the concentration of water? I have 10 sodium per liter. So you have 1/10 liters of water per how many sodium? Per 1 sodium. So the concentration of water outside is 1/10 to 1 sodium. Concentration of water inside the cell is 1/4. So which one has more water, higher water concentration? We're not looking at the sodium now, we're looking at the water. Here I have a quarter liter per sodium. Here I have 1/10 liter per sodium. Which one has more water? Which one is greater, quarter or 1/10? Inside has more water compared to the outside. So the first information I want you to remember that having high solute concentration means I have low water concentration. And having low solute concentration means I have high water concentration. Do you agree on this statement? Do you agree on this? Do you agree on this? All right. So now I have high water inside compared to low water outside. So which side has more water now? Which side has more water? Inside. We did agree on this. So according to what you've learned, if I have high concentration on one side, what's going to happen if I have low concentration on the outside, on the other side of the cell membrane? You're going to be moving from high concentration to low concentration. All right, do you remember this? We move from high pressure, high concentration to low concentration. So now, which side has high concentration of water? Which side has low concentration of water? Inside has high concentration, outside has low concentration. So what happens in here? The water is going to be leaving the cell to the outside. So the cells, they are not able to get the sodium in. So what will they do? The water will leave instead, because I can't get the solute in. So the water is going to be leaving from the side with lower solute. This is the side with lower solute to the side with higher solute. Why? Because you know that low solute means high water. So it's going to be traveling from high water to low water. Inside is high water. So water is the one that travels. I'm not able to allow the solute to travel. Is this clear? Is this clear? So some things that you can try at home. You are home already, so you can try it now. So get some fruits like strawberries. All right. Put them surrounded in a cup. Put some of them in a cup, and we put sugar on top of them and leave them in the fridge for a day. And come after that, what you're gonna see? Put a lot of sugar on top of the strawberries. What's gonna happen? When you come on the next day, you will find that the fruit is shrinking and the water is coming out. So you're gonna have a lot of juice surrounding the fruit. What happened in here? The amount of sugar that you did add creates a state of high solute outside. So the fruit itself now, it cannot get the sugar inside. So what's going to happen? The water is going to be pulled out. All right, so is this passive or active? Did I need to consume energy for this water to move? Is this passive or active? It's passive. I didn't consume any energy. I didn't pay for the water to leave the cell. All right, it's passive. What do I call this passive transport? I'm not moving the solid, I'm moving the solvent, I'm moving the water. It's passive, but I'm not moving the solid, so I cannot call it diffusion. I will call it osmosis. So osmosis is simply the diffusion of the solvent. So the water is the one that's going to be moving. Why? Because simply you cannot allow the solute to travel. If I did have channels for the sodium would have trouble. I didn't have a problem with that. But because I am not permeable for the solute, so what's going to happen? The water is the one that's going to be trapped. Right. Is this clear? Is this clear? So let's see here. So let's answer this question first. In your for your in-class activities, this is question number two. This is question number two. I need to take this call, so can you just stay with me for a second? So they let's start. So no problem. So let's keep going. So again, what was your answer? Which of the following is a cell junction that allows cell-to-cell communication? The ones that allowed the signals to travel freely between the cells. What do we call this? We call it my gap junction. Gap junction. All right, so what is osmosis? Again, as we mentioned, osmosis is going to be determined by the solute concentration. It's when solutions of different osmolarities, osmolarity is a measure of total concentration of the solute, are separated by a membrane, osmosis will be taking place to reach equilibrium on both sides of this membrane. So we're looking on here. This membrane, you see on here, I've got a tube, has two sides. This side has a higher solute concentration compared to this side. So what's going to happen? If the membrane was permeable for the solute, if the membrane is permeable for the solute, what's going to happen? The solute is going to be traveling by diffusion from high concentration gradient to low concentration gradient. What if I had a membrane that is impermeable for the solute? So the solute cannot travel. So what can I allow to pass through the membrane? I will allow just the water. So the water here is going to be moving from the side with low solute concentration to the side with high solute concentration. Because remember, if I have low solute means I have high water. And having high solute means I have low water. So the water is the one that's going to be traveling from high water to the side with low water. What do we call again this membrane transport? It's osmosis. Osmosis. All right, don't forget trying this out. Don't forget trying this out. All right, so let's check on here. And a clinical application for the osmosis. If this is my red blood cells, the red blood cells are biconcave discs like this. And which side do you think gonna have higher solute concentration, outside of the cell or inside of the cell? Which one has more solutes? Outside or inside? What do you think? Which side has more solutes? Outside. So I will make a rank here. So for the people who say outside, and how many would say inside? So you've got one outside, one inside, one outside, one inside. Any other? We've got three outside. What do you think? inside, inside. So in order for you to maintain normal function of the cell, which one should have higher solid concentration, inside of the cell or outside of the cell? This is my question. So which side has to have higher solid concentration, inside of the cell or outside of the cell? So let's try first outside. So if this is my cell, like this, and I did have higher solid concentration outside, so you have more solids outside than inside. So what's going to happen? The cell is not going to allow this solute to travel in. I will not allow it. But what can I allow is water. So where is the water going to be moving from? Will it be moving in or out? Remember, water moves from low solute to high solute by osmosis. So will it be moving in or out? Again, water is moving from where to where? From low solute to high solute. It's moving from low solute to high solute. I'm telling you here, this is high solute outside, and this is low solute inside. Where is the water going to be traveling? Will it be moving out or in? A or B? What do you think? It's moving out. So what's going to happen to the cell? If the water is moving out, the cell will shrink. Would you like this to happen? Would you like this to happen? Would you like the red blood cells to shrink and not to be functional? No. So what's gonna, would you be, which one would you be picking now? Which side should have higher concentration of solute, inside or outside again? So it cannot be outside. Remember why? Because if I did have high solute outside means the water is going to be leaving the cell and the cells will shrink. So which one is the correct answer now? So let's try inside. So let's see here. This is my red blood cell. And you're saying here that having high solute inside is going to be better than having high solute outside, right? So which side would the water move? Water moves again from low solute to high solute. So where is the low solute? Outside. Where is the high solute? Inside. So where is the water is going to be moving? Inside or outside? The water is going to be moving towards the inside. So what's going to happen if the water did move inside the cell? The cell will be swelling. The cell will be swelling. And what's going to happen when the cell swells? It bursts. Would you like the cells to burst? What do you think? Would you like to have higher solute concentration inside your cell? No. So which one is a good answer? Neither. You want to have the same solute concentration on both sides of the membrane. You don't want to have high solute outside of the cell or high solute inside of the cell. They need to be equal. So you see on here, if the cell is in a hypertonic solution. What I mean, it's in a higher solute, in a solution that has higher solute concentration, higher solute. So what's going to happen? The water is going to be losing the water, the cell is going to be losing the water out. And the cell will do what? Will shrink. Hypertonic. How about here? Hypotonic. I have low solute in the solution where the cell is kept. So what's going to happen? Water is going to be moving in. And when water moves in, what's going to happen to the cell? The cell will be swelling and bursts. So I don't want to have shrinkage of the cell or swelling in the cell. So what do I need to have? I need to maintain the shape of the cell. So how would I maintain the shape of the cell? By having equal solute concentration on both sides. So the amount of solute outside is equal to the amount of solute inside of my cell. So there is no net gain or net loss of water. So there will be gain and loss of water all the time. The water moves in and out, but there will be no net gain or net loss. So the intake is equal to the output. It's gonna be the same. So your cells are not sweating, your cells are not shrinking. They are capable now to maintain their shape. All right, so it was a trick question. So actually none here, none of them was the answer. All right. So again, which side should have higher solute concentration, extracellular fluid or intracellular fluid? Which side should have higher solute concentration, outside or inside of the cells? Neither. They should be equal. Again, why equal? Why equal? For me to maintain the shape of the cell. What do we call the solution that has the same concentration as the same concentration of solutes as your cells? This is an isotonic. Iso equal or constant. So isotonic solution, it's a solution that has the same concentration of solutes. This is the one that we do have. So when you are expanding the blood volume, you're going to give isotonic solution to your patient in case of blood loss. All right, so we didn't have much questions today. We did have only 2 questions in the in-class activities for today. All right, so this completes our discussion for today. Next class, we're going to be discussing the cell organelles and the cell cycle. So please